Hey guys, David here, founder of Superthread, and welcome to my devlog. So in this devlog, I want to talk about microservice architecture and how we use it at Superthread. I also want to talk about monolithic architecture and how we went from monoliths to microservice architecture and what the advantages of using microservice architecture are. But before I begin, check out my new t-shirt. It's a kind of commit history, Golang, Superthread themed t-shirt. If you guys want to win one of these t-shirts, go to www.superthread.com and sign up for early access. Right now we're looking for early access testers. We want to hear what you guys think about the product we're about to launch in early access, and we'd really appreciate it. So without further ado, let's begin. So the way things used to be done in the past is normally you'd have one server, one machine, which would be running something like Linux or Windows. And then on that machine, you'd be running your app, such as, say, a shopping cart. And on that machine, you'd be running your database as well. And, everything would be on that machine. And if that machine flaked out, if it crashed for some reason, your whole site would kind of go down. So then people started kind of separating databases away from the machines. So probably they would have something like a machine running the app, and then that kind of app would be talking to a database which would be on a separate machine. So that used to make things more reliable, but still not quite reliable enough. So that's what we would call a typical monolithic architecture. So one app, everything running inside of one app, and then all the endpoints being there. And then people started separating that same app into two different machines. So they'd have the same monolith running across two different machines, and in front they would put something like a load balancer. So the load balancer would kind of go round robin between these two different machines. And if you wanted to update your app, let's say you made a change to it, the way it used to be done would be like you'd kind of take out one of the machines from the load balancer. So the load balancer would be just pointing to one of them. You'd make an update and then add that machine back into the load balancer pool, and then do the same with the next one. That was kind of the way things were done for a long time. But then people were kind of thinking, well, how can we make it even more reliable? So then people kind of started adding more machines and so on and so forth. Again, separating databases out onto different machines. And that's how things went on for a long time. And then people started thinking about how can we actually take the actual app, say a shopping cart, and separate it out into different kind of bits, so that if one part of the actual app went down, the rest of the app would work. Say, for example, you have a shopping cart and your search microservice goes down, the shopping cart still works, so you can still register, you can still log in, you can still kind of edit your kind of profile, but you can't search for items. So that's kind of the idea behind separating bits out. Other bits you can kind of separate out in such an app would be, let's say, registrations. That could be a separate microservice. And then the actual cart itself, that could be a separate microservice. So let's say the cart microservice goes down, the rest of the app would work. So you could still kind of search, you could still kind of browse the catalog, you could still log into the admin area and add items to the catalog, but the actual cart itself wouldn't be working until you kind of bring it up. But normally when people do that, at least the way it used to be done, is they would still talk to the same database. So if the database flakes out, the whole thing would go down. So it's kind of more microservice-y than, let's say, monolith, but still kind of it has this kind of one single dependency, which doesn't make it completely microservice-y. What people then started doing is separating each microservice into its own app and database. So if the database goes down for that particular microservice, say a search database, only the search would go down, but everything else would continue to work. But then you had a problem of how do you actually communicate between these microservices. So say a microservice like a shopping cart, so the search would need to talk to the actual main database to get the record into the search engine. And that would be kind of something that you'd have kind of interdependencies between these microservices. So Google actually invented a protocol for that called gRPC. You should check it out on the internet. But basically you had microservices, many of them. It's all very well that they're separated, but they were still talking to each other, and then kind of the dependencies between them were very complex, and there were many of them, and I think that would end up making things more kind of flaky. In essence, you ended up with something like a distributed monolith. And that's not even ideal. So what we have started doing at Superthread is that we kind of try and architect everything so that each microservice is as independent as possible. It has to talk to other microservices as little as possible where it's basically allowed. So that kind of makes it kind of more stable and more kind of solid. So that's the idea behind what it means to have a decent microservice architecture. So as independent as possible, has its own database, and it doesn't talk to other microservices if at all possible. The more it talks to other microservices, the more you're kind of heading towards this kind of distributed monolith rather than having a proper microservice architecture. So now that we have this microservice architecture, what are the advantages of having this microservice architecture? First of all, you're separating out the code into smaller components. So for human beings, it's easier to actually cognitively comprehend and understand and read through a smaller chunk of code, a smaller project, than actually having to go through the whole bunch and actually see how everything is interconnected together. And the more it's kind of separated and independent, the easier it is for developers to come into it and understand it. So at Superthread, I keep saying to my developers that a microservice shouldn't take longer than 2 weeks to develop, because if it's actually longer than that, then it's a bit too big. Then we should look into kind of breaking it apart. The other thing that you should do is not have too many microservices. So when you have above 10, it's more difficult for people to kind of cognitively understand as to what's going on in the system holistically. So kind of keep it around 10. That's kind of the rule we have at Superthread. Keep them quite small. One developer should be able to get in and understand what's going on very quickly. One microservice shouldn't take more than, let's say, 2 or 3 weeks to develop. It should be kind of as independent as possible from all the other microservices. And then basically you have a robust system. So now we come to how do you actually orchestrate? How do you actually serve these microservices? Well, these days things are much easier than they used to be. In the past, basically people used to kind of make manual things where, they would measure the load and they would spin up another instance of a microservice and add it to the load balancer. But nowadays we have things such as Kubernetes, where it kind of orchestrates everything for you. So it kind of measures the load that you have, and then if you have more load, basically adds more instances of that particular microservice to the pool inside of the load balancer. Now, Kubernetes is quite good, and it seems to be the most popular way of orchestrating microservices these days, but in my experience, if it goes down, it's very difficult to determine as to what's going on. I would like you to consider that other offerings. So, for example, Amazon has its own kind of offering you should look into. It seems to be a little bit simpler. One way or the other, there are ways of now automatically orchestrating your microservices. So once you end up with this kind of real kind of proper microservice architecture, where all the microservices are independent from each other, where they have their own databases, and where you are orchestrating them with something where you have visibility as to what's going on inside, and if things flake out, you can actually quickly look into it and fix it, then you have a strong, solid backend architecture that's going to serve you well. What do you guys think about microservices? Leave a comment down below, and we look forward to seeing you in our next video.